You put it that way.
I didn't know if you did that intentionally or... Okay, what do we got
Yeah.
today?
Well, today there's a few problems that I need to work on.
Okay.
All right. Okay, so I have this one at the back right here.
Are you going to be able to verbalize them or you need to send me a picture?
I'll be able to verbalize them.
Okay.
So the first one is the function h equals negative 16 t squared plus 50t represents the height y, which is in feet, of a football um t seconds after it's kicked off the ground.
Okay. I
And
get
we
it.
have to identify the
That's
vertex.
actually the equation of projectile motion.
Yeah.
Whenever gravity is involved, you always have this kind of an equation. If you throw a ball up in the air, it follows this kind of an equation. The
All right.
16, the 16 has to do with the force of gravity. The 50 is its initial velocity in an upwards direction.
Okay.
Whatever the coefficient of t is, that's what it means. It's the velocity that the football is kicked in an upward direction. I think. Go ahead and read the rest of the problem.
So the first part is we have to identify the vertex.
Okay. So
Um,
if I
yeah.
draw a picture of this thing, I could kind of think of it like that, right?
Yeah.
Okay. So this is a quadratic. The x-coordinate of the vertex, have you learned this yet? Minus b over 2a?
Yeah.
Okay. What's b and a in this case?
Um, would A be HT?
No.
That'd be 16.
A is the coefficient of the squared term,
So
and
16?
yeah, minus 16. And b
Yeah.
is the coefficient of the non-squared term.
Oh, so it'd be a positive 16 over 100, right?
Now, let's do negative b first. B is 50. So it's negative 50 over 2 times negative 16. That's negative 32. So that ratio, that's equal 50 over 32. And what that means is that at that time, almost 2 seconds, a little less than 2 seconds, the football will reach its peak height. In other
Okay.
words, that measurement right there is 50 over 16, which reduces to what? 25 or 25 over 16? Yeah,
Yeah.
that's 25 over 16 on the t-axis. Okay?
Yeah.
What's the second question they ask you?
So the vertex is 25 over 16?
No? Oh, they want the whole vertex? Well,
Yeah.
we also got to figure out what the y-coordinate is. In other words, the x-coordinate is 25 over 16. How do we get the y-coordinate?
Um,
Plug it in
huh.
the h of t equation. And this
Yeah.
incidentally is how that's pronounced. It's not just h, it's h is a function of t, so it's called h of t. It's like f of x, only x isn't our variable, t is. And you can use any letter you want to designate a function. So h of t equals this. And to get the y-coordinate of the vertex, plug in the x-coordinate into the original equation. In other words, I should say the t-coordinate, right? So the t-coordinate, where the peak occurs, is at 50 over 32. So now let's plug that in. Minus 16 times 50 over 32 squared plus 50 times 50 over 32. That will be your answer for what the height is. And
Okay.
let's see, I think I can do that. Let's see. If I reduce, let's see, that's 2,500. That's 32 times 32 plus 2,500 over 32. I can cancel one of those 32s with that 16 and replace it with a 2. See how?
Okay.
Okay. Now what we have is minus 2,500 over 64 plus 2,500 over 32. How do we add those two fractions?
We just multiply the right side by 2 over 2.
Okay. So we end up with 5,000 over 64. And now we can add the two fractions, and when you add them together, you get 2,500 over 64. So that's its height. And
Okay.
you could reduce that or simplify it. It's about 4. Let's see. It becomes 1,250 over 32. I can cut that in half. That's 625 over 16. And I'd cut that in half or do anything else with it. So the height is 625 over 16. So the y-coordinate is 625 over 16. And this spot right here is 625 over 16. So about a second and a half after the football is kicked, it reaches its height, and its height is approximately 40 feet. Whatever 625 over 16 is, close to 40.
Mm-hmm.
Okay, what else do they ask? They're going to ask you, when does it hit the ground, right?
Well, they ask how long the ball was in the air for.
That's the same thing. In other words, it's in the air for this amount of time, right?
Mm-hmm.
Okay, so how do we figure out what that point is on the t-axis? That'll give us our answer.
What that is?
What is h? What's the height equal to there?
It's the rise.
Huh?
Y.
What is it equal to? When the ball hits the ground, what is its height going to be?
0.
Okay, that's what we want to put in for h of t. H of t is 0. I'm going to substitute 0 for that, and then I'm going to solve it. And that's going to tell me when it hits the ground. Okay, well, the easiest way to solve this is to factor out 2t. Okay, in fact, factor out minus 2t. Minus 2t leaves you 8t minus 25, right?
Okay.
You with me? If I lose you in the algebra, by all means stop me.
Okay.
So all I'm doing is factoring out a greatest common factor. Now, I've got either that has to be 0 or that has to be 0. Because the only way you can multiply two things together and get 0 is if one of them is 0.
Yeah.
What I do at this point is I set minus 2t equals 0, and I set 8t minus 25 equals 0, and I solve each of those. So the first one produces t equals 0. Second one produces t equal 25 over 8. Which, notice that there were two zeros. And the first one is 0. When the football was kicked, it's on the ground. So at time 0, the football is on the ground at a height of 0. Just like our picture looks like. So the second solution must be this solution over here. The answer to their question is it's in the air for 25 over 8 seconds. That's 3 1/8 seconds.
Okay.
And that makes sense. If it hits its peak at about 1.5 seconds, it should be in the air for a total of a little bit more than 3.
All right.
What else do they want to know? That's probably it.
Yeah.
Okay.
All right. So I have this next question.
Okay.
And then after that, I need to know like as much as I can about
Okay, we only have
quadratic.
okay, I can definitely do that, but we only have 15 minutes. I have a 5 o'clock that I have to go to also.
All right, so this one question is, you drop a ball from a 5th-story window that is 96 feet above the ground.
Okay.
The ball's height at any time, t, is given by h equals...
h of t.
Yeah, h equals negative 16t squared plus s.
Plus what?
S.
Okay. S being the height.
No, h is the ending height and s is the starting height.
Right, that's what I meant. S is the starting height. In other words,
Yeah.
S is 96 feet.
Yeah, how long does it take for the ball to hit the ground?
Okay, so I'm going to first of all replace S with 96.
Yeah.
Now I have to solve, how do I solve that?
Would you...
What is the height going to be when the ball hits the ground? You always have to ask yourself that question.
Oh, h of t is 0.
Right. So I'm going to make that 0. That's what its height will be when it hits the ground. So now I just have to solve this equation. Okay. How do I solve that?
Hold up. Always 0. Yeah. Yeah. 1 second.
Mm-hmm.
My mother needs her card.
She needs what?
Alright, so 0 equals 16t squared plus 90. Would you add the 96 to the 0? Or subtract it?
Subtract. Yeah, so now I got minus 96 equals minus 16t squared. Next step?
Would I... Eesh. I don't really know where to go from here.
Well, you're trying to isolate t. So anything that's affecting t, we have to do something about. Well, we got it's being squared and it's being multiplied by minus 16. So how do we get rid of the minus 16?
Well, we could divide each side by minus 16.
Well, that's a good first step. That gives you 6 over here and leaves t squared over there. Now how do you get it down to just t?
Oh, we need a square root each side.
Correct. So t equals plus or minus the square root of 6. Remember, whenever you solve an equation where you're taking the square root of both sides, always begin your answer with plus or minus. However, in this particular problem, the minus can't be a solution. Time is never negative. So when you're solving for time and you get a negative answer, throw it out. So what t is actually equal to is just the positive square root of 6, and that's when it hits the ground. What is that, 2.5 seconds? Something
Yeah.
like that. I don't know if she wants you to give your answers in radical format or round it to a decimal. What typically does she do? How would you give your answer on this problem? Would it be square root of 6 or would it be 2 point something? Nick, I think I lost you. I don't hear you anymore. Oh, boy. Nick, you still there?
Yellow.
Yeah, you went offline. I'm not. Are you back?
No, it says it's connecting to audio.
Okay, well, we can do the audio by phone. The problem is you're offline and you're not going to be able to see my screen. I'm writing a number on my screen right now. Can you tell what it is?
No, I do not see it.
No, because you're not in real time. In other words, you're no longer in the meeting. You need to log off and log back on. Just use the same meeting ID number. I won't do anything. But whenever that happens, that's the fix, is to log off and then log back on. So I'll talk to you in a minute as soon as you get back in. Well, hold on. I'll stay on the phone with you just to make sure that your computer, you didn't lose your internet connection or anything. Make sure you can log back on, yeah.
It's kind of slow laptop. It takes a while to pull up.
So anyway, my question to you was, do you give your answers in radical format, or does she ask you to round them to a decimal?
I said she really okay.
Okay. I would give it in radical format then. The answer to this question is square root of 6. That's the most precise answer. That's far more precise than any number you could write, because any number would have to be rounded up.
Okay, and then after that I need to find out how to find Y-intercepts, axis of symmetry, to a vertex's max or minimum, and find the vertex.
Okay, it's actually pretty easy to do all of those things.
Or identify the x-intercepts.
Go ahead and if you can get back online, I can probably cover all of that with you in 8 minutes that we have.
Yeah, but I'm trying to pull it up.
Is it not loading when you try to, you didn't have any problem signing off, did you?
No.
And then when you went to get back on, it didn't load up go to meeting, is that right?
Yeah, it's just not pulling it.
I bet you lost your internet connection. I bet if you open up your browser, you cannot go to a new web page. I'll tell you what, let's just do the last 7 minutes by phone.
All right.
Okay?
All right.
So, hold on a minute. I need to write. I don't think I can teach math without writing. So you have a quadratic, okay? Do you have a piece of paper and pencil in front of you?
Yes.
All right, let me give you a quadratic. Y equals x squared minus 7 plus 7, no, minus 7x plus 10. Okay, there's a quadratic. Now, you need to find what are the following things. You need to find the axis of symmetry.
The Y-intercept, the vertex, determine if the vertex is max or minimum.
The axis of symmetry is the x-coordinate of the vertex, right?
Yes.
What's the x-coordinate of the vertex equal to?
Negative b over 2a.
And what is that in this particular quadratic that I gave you?
Would it be, oh wait, I get this, so it's positive, so it's 7 over 2.
Correct. And the axis of symmetry is actually a line, and so you can't just say 7 over 2. That's the x-coordinate of the vertex. But the axis of symmetry is x equals 7 over 2.
Okay.
In other words, you have to give it as an equation of a line. Okay. The y-intercept. Remember the following statement. Y-intercepts always come when x is equal to 0, and x-intercepts always come when y is equal to 0.
Okay.
So what's the y-intercept here?
So in this equation, x is equal to 1.
No. X is always 0 if you're talking y-intercept.
Okay.
So plug in x for 0, and what do you get?
Well, we get negative 7 plus 10.
No, not if you plug in 0 for x. The x squared term goes to 0, and the negative 7x is 0. Remember, any number multiplied by 0 is 0.
Oh, so it's just 10.
Just 10. And it always is just the number. So the y-intercept's the easiest thing in the world to find. It's the constant. It's always the constant. In other words, whenever you're substituting 0 for x, it makes the first two terms disappear. So the y-intercept is 10. The vertex, well, we've got the x-coordinate of the vertex. That's 7/2, right?
Yeah.
How would we get the y-coordinate of the vertex?
Would it be the y-intercept?
No. We're talking the vertex here. Remember, we're looking at a parabola that's facing upwards.
Oh, yeah.
You would plug in the x-coordinate, and whatever y comes out to be, that's the y-coordinate.
Okay.
We know the x-coordinate is 7/2, so the y-coordinate is going to be 7/2 squared minus 7 times 7/2 plus 10. See how I got that?
No.
I'm merely substituting the x-coordinate of the vertex into the original function for x.
Okay.
That gives me y equals 7/2 squared instead of x squared. Gives me minus 7 times 7/2 plus 10. You see how I got that?
Oh, I see now.
Okay. Now let's square it and simplify. This becomes 49 fourths minus 49 halves plus 10. Well, if we find a common denominator, then this is minus 49 fourths plus 10. 10 is 40 fourths, so our answer is minus 9 fourths.
Okay.
That's the y-coordinate of the vertex. So your vertex,
7/2 and 9/4.
yeah, minus 9 fourths.
Yeah.
7/2 minus 9 fourths is the vertex. How do I know if that's a maximum or a minimum? Picture the parabola.
Okay.
Does it open up or down?
It opens up.
So is it a maximum or a minimum?
Minimum?
Yes. If the parabola opens up, the vertex is always the minimum point on that entire graph. If the parabola opens down, then that vertex is a maximum.
Okay.
That's how you tell whether it's a maximum or a minimum as to whether it opens up or down. But you can definitely see it. If you draw a parabola, you can see that if it opens up, you're looking at a minimum when you look at the vertex.
Yeah.
Okay. I hope? Because I got to go in 1 minute.
Can you show me how to identify the x-intercepts?
Yeah, the x-intercept is where y equals what?
0.
Okay, substitute 0 for y and solve that equation. That's the standard way you solve a quadratic, is by setting it equal to 0, because what you're solving for when you solve a quadratic is the x-intercepts.
Okay.
And that gives you x minus 5 times x minus 2 if I factor that quadratic, correct?
Yes.
So the x-intercepts are where? If this quadratic factors into x minus 5 times x minus 2, where are your x-intercepts?
What are they or where are they?
What are their values?
They're just the opposite of what that
Right.
number is.
So they're at 5 and 2.
Yeah.
And you have 2 of them because the parabola goes through the x-intercept, so you're always going to have 2 zeros as long as it goes through the x-axis. It doesn't always have to go through the x-axis. If it doesn't cross the x-axis, then you have imaginary zeros. But this one does. I made this a nice simple quadratic. So all you have to do is factor that quadratic and you know your zeros. And those zeros are not only zeros of the function, but they're the x-intercepts of the function also. Those two terms mean the same thing. Okay? Good to go?
Yeah.
I hope your sister's going to use a different computer. Is she using the same one?
I believe she's going to use her computer.
Okay. I will text her meeting ID number in a half hour.
Good.
Thanks, Nick. Talk to you later.